Max Pumperla, who wears many different hats, one of which is deep learning engineer at Pathmind, but we'll get to discussing the other things that Max does. Welcome to the Data Exchange podcast, Max.
Yeah, hi. Thanks for having me.
So first off, actually, as we were about to record this podcast, you shared some personal news with me, which is you just joined a German university as a faculty member. So maybe let's break that news to the audience here. So what exactly is this new gig?
Yeah, cool. Thank you. So the recent gig is that I joined the faculty of this public applied university in Germany, and it's a professorship in data science. So I'm doing this professorship part-time explicitly, so I can continue doing my job in the industry as well.
So
right. So it's kind of.
So how do German universities, Max, define data science?
Nobody told me their definition yet. So I guess it's on me to help shape it.
So what kinds of courses will fall under the purview of data science in this university? By the way, which university?
So it's called IUBH, International University in Bad Honnef, which is close to Bonn.
Okay, great.
Right, so it's an applied one. Yeah. So and I will mostly be responsible for teaching engineering heavy parts of data science. Yeah. So I will, for instance, be involved in a course that teaches software engineering principles for data science. So the foundations of that. Right, because oftentimes what we see in the industry out there is that data scientists kind of manage to learn about the statistics part. Maybe they grasp the mathematical concepts and they can dabble in Jupyter notebooks and so on, but they're not ready to jump into a company and build production-ready code. Right. So this is something that should be addressed at some point. And so this is one thing I do, and another course would be, for instance, big data technologies, right? Which is another fundamental course, if you will. And of course, you have to know what's going on, understand the underlying principles, technology choices, so that you can architect interesting solutions for the companies you will be working.
So it sounds like the types of students you'll produce are going to be very practical, will have strong engineering backgrounds, and can dabble in data engineering as well.
Yeah. So that's kind of the understanding that I bring to this university, and it was also like this direction that I like most when I decided to join, right? Because it's fairly practical minded, as you said, but they also respect that part of data science, which I think is fairly interesting and has shaped a lot of my career so far as well, right? So I've done as much data science as I've done data engineering. So
where does this program sit inside this university? Is it inside computer science, or is it interdisciplinary? So how is it structured?
Yeah, so it's a new department, if you will, and so it comes with like a bachelor's and master's in data science, and they also have an AI track in their master study. But I mean, it's obviously adjacent to a lot of things, but mostly computer science. And yeah, sure, but obviously, I mean, there's a lot of courses that you can take from other disciplines as well, and that would apply, right? But it's just a new course that you can study there. But interestingly, one thing I wanted to mention is also that I think this is quite a modern approach as well, because this is actually remote studies. So I won't be there, right? So I'm doing this full remote lifestyle also in the other part of my work, and so I can continue doing so. Yeah.
To place this program in the context of higher education in Germany, are there a lot of data science programs in Germany now?
Well, they're popping up more and more so, but it's sometimes I have the impression that like the older classical universities are slower to act, which makes sense, and then also I mean, just because they're slow to act in general, but it's also true that as we just discussed, data science is fairly interdisciplinary, right? And it's also by its nature, at least how I understand it, a very applied field. So it almost doesn't make sense if you look at like the classical Venn diagram, right? To take out the business part of the equation, right? If you'd only do the math and the computer science part, so to speak, it doesn't quite work out. So at like a more theoretically minded university, does it really make sense to have a data science study there? Yeah. So I think it's like the concept has been around for quite a while, right? We talk about data science for, well, a decade or what, and more so, I think. But still, I mean, it's still evolving, and I think even in the industry, like what we expect from the field and what we expect from applicants and junior data scientists and so on, still changes every year, basically, and so it's also difficult for universities to shape proper courses, right? That are kind of future-proof and really deliver what the industry wants. So it's no easy business, I think.
So one last question on this topic before we move on to reinforcement learning, which is so since this program appears to be more applied, if you were to take this program and put it in the US, I would say that internships would be a big part of this program. So is that something you folks are thinking about in terms of maybe in the summers, helping students secure internships?
Yeah, possibly. Yeah.
Yeah.
So this is something I cannot really judge yet, but I'm on the same page with you. I think it is important, and we should place students in internships. Yeah.
Yeah, because in many ways, actually, I mean, there's a lot of smart people in universities who can pick up the concepts that you need for data science right away, but there's nothing, Max, like working on a real world problem with real messy data.
Yeah, true.
Having to get data from awkward systems and things like this that you only learn if you maybe spend some time in a company, right?
Yeah, but one thing you should keep in mind is also that because it's remote studies, it opens up a completely different path as well, because some of the students might do this on the job, right?
That's great.
It might be slower, but I think this is something that classically cannot be done, because you need to be there physically in presence. And so some of the students might already be on the job, right? So maybe not in the field they want to be working in, but maybe in an adjacent field, right? And they want to grow into a data science role. So maybe they don't need the internship because they can evolve into that role in their company, possibly. So
one of the aspects that's somewhat underappreciated with data scientists is, interpersonal and communication skills, right? So presentation skills, listening skills, and teamwork skills and stuff. So how do you teach these online and remotely?
Yeah, interesting. I mean, I guess it's difficult to incorporate these directly into the curriculum as such, but certainly like one of the goals of many of the courses will be, in the end, the students have to give like an oral explanation, like a presentation of study content. So instead of having like a classical exam, which you can take online either way, so it doesn't need me. It's like you can take the exam at 4 a.m. in the morning if you like, if that's what you want to do. But on top of that, you also have like presentations on certain topic matters inside the course, right? So you choose a big data technology of your choice, and then you present it. and that is part of the examination, right? And so it's in front of a live audience, and I think that will certainly help with communication skills as well.
So the main reason I have Max on the podcast for our audience is Max is also spending time at Pathmind. Full disclosure, I'm an advisor of Pathmind. And they are doing interesting things around reinforcement learning and simulation software. And in fact, Max is scheduled to give a talk at the upcoming RACE Summit, which is a free virtual conference, which I encourage you folks to check out. We have a great lineup, including Max. You can find details at racesummit.org. So Max is giving a talk called Connecting Reinforcement Learning to Simulation Software. So first of all, Max, I think many of our audience have heard of reinforcement learning, but what is this thing called simulation software?
Yeah, interesting. Yeah. That's a good question. Yeah. So, I mean, I think I start my talks for Pathmind always with prefacing that basically reinforcement learning software always operates on simulation software, right? So like what we do with computers is a digital version of something, right? We simulate a process of sorts, right? And so it's not surprising that we talk about simulations when we talk about reinforcement learning, right? Like a classical example that everyone's aware of now is game AI. So in particular, maybe the game of Go or something like that, where techniques like reinforcement learning come in. And so, of course, that is a simulation of the game, right? And so, but what we mean at Pathmind when we say simulation software, it's actually a different kind of animal.
It's
enterprise.
A whole industry.
There's a whole industry.
A whole industry. Yeah, massive.
Some
of the companies are big, right?
Yeah, they're really big. So I'm not good with like stating any concrete numbers, but there's a huge market of enterprise simulation software that most data scientists, me included, a few months ago was completely unaware of. Essentially, right? I mean, some of the tools you might have known from other backgrounds, so to speak, like I don't know. Like the stuff that MathWorks does, MATLAB and so on. So they have a tool called Simulink as well. So that's simulation software, or Mathematica does something like that as well. But maybe those aren't the first tools you think about. Well, maybe let's say the biggest one that comes to mind, or like the one that's most interesting for Pathmind is actually AnyLogic. And
so what are the applications of these?
This is
Max, what are the applications of these tools inside companies? And inside companies, who are the personas using these tools?
So larger companies have simulation models that model all sorts of processes in these companies, right? So, for instance, in my talk, I give an example of a big car company. And you have several production steps in a huge factory. So, and the factory grid is laid out for you, but the ways in which certain parts in your factory flow can move are fairly restricted, and the parts cannot really pass each other and stuff like that. So this is perfectly suitable. This is a perfectly suitable application for a simulation, because you can test out stuff on the computer without having to mess with the actual physical factory, right? And so stuff like supply chain or job scheduling or coordinated routing, like how does A get to B efficiently and stuff like that, or simple cost minimization problems in such factories, and yeah, could be examples.
So
of
are
that,
these,
right?
I think many of our listeners may have heard of things like solvers, optimization tools. So do you place these simulation software in the same bucket?
So many of the simulation software tools come with integrations with classical solvers, so to speak. Yeah. So like convex optimization.
So any kind of problem that can be cast as an optimization problem falls in the purview of these software in some ways.
You mean, well, I mean,
because some of the things that you described, like logistics, is in some ways like an optimization problem, right? So.
Well, you can formulate a lot of problems into an optimization problem, but it's not clear if like the algorithms you have available in optimization are actually feasible for that problem. So that's a different thing, right? You can always try, given that you're able to formulate it in the correct way. So like mostly you have certain variables and linear constraints usually that you have to put in. But you also have to be able to clearly formulate your goal, for instance, and it can be sometimes fairly difficult to craft explicit solutions for that.
So, by the way, once you see the user interface of the simulation software, it kind of makes sense that reinforcement learning might be helpful because, as you point out, Max, people are probably aware or familiar with some of these research projects and articles written about how reinforcement learning was used in multiplayer games and things like this. So some of the simulation software in many ways have kind of they could look like a game of some sort, right? So you can imagine why reinforcement learning may play a role. So quick question. So you mentioned people who you described as simulation modelers. So what are their backgrounds and are they familiar with reinforcement learning?
That's a very broad question. So I don't know what their backgrounds usually is, but I guess it depends on the particular company. Yeah. But I guess some general engineering background would make sense. But mostly what we see is that they don't know reinforcement learning or machine learning in general, right? And well, it's also mostly not obvious how to use your usual toolbox for reinforcement learning, which might be mostly within the Python ecosystem. How would you connect them to those simulation software tools? And this lies at the heart of the value proposition of Pathmind, if you will, right? Because we build a bridge to connect simulation software to your reinforcement learning toolbox, if you will, but on a very low code level, so that you don't have to become an expert in reinforcement learning. You just have to basically suffice a certain interface so that the Pathmind backend can pick up your simulation.
So quick question, Max.
Model and run a, yes.
Quick question, which is, so you said you connect reinforcement learning to the simulation software backend. So for those of us who don't follow simulation software closely, why would I want to do that? Because don't the simulation software tools solve my problems?
Yeah, I mean, you asked about optimization, and I told you that not always does the optimization tools do they solve your problem, right? And just because you have a problem simulated, like think about board games again, just because you can build a chess engine and know how to make moves doesn't mean that you know how to make smart moves, right? So and it's not obvious that a certain paradigm or a certain way to approach a certain problem would solve your problem, right? So we have certain use cases in which we can outperform certain heuristics used from our customers. So used by our customers by using reinforcement learning algorithms, right? So this is why you want to look at different solutions, right? Because not always is your problem statement cut out to be solved by classical methods, or maybe you didn't even know how to go about it, right? So and this is where reinforcement learning can help you, right? I mean, it's not always the best choice if you can do it with a solver that's already plugged into your tool. You might not need it, but well, there are certainly a lot of examples where people still have problems to optimize their processes, and look out for new ways to do it, right?
So the reinforcement learning, even among people who use machine learning, is not something they use day to day, right? So there's certain quirks to using reinforcement learning. There's terminology that's specialized in reinforcement learning. So that's with people familiar with machine learning. Now you're trying to introduce reinforcement learning to people that you describe as not even familiar with machine learning. So what kind of educational process do you have to go through to convince them that this is viable?
Yeah, so one thing you notice is, of course, there's a certain learning curve, and you have to introduce people to the concept. But it's quite interesting to see how sometimes the terminology between simulations and reinforcement learning kind of agrees. Like if you look at what we call an environment in the reinforcement learning world, right? Agents interacting with an environment. It's actually quite similar to what the simulation modelers do, right? So the environment has the state space or the observations, right? And agents do actions, right? And once they act, their environment changes, and then they output a new state. But this general process that you have actors within a simulated world comes fairly natural to the simulations, right? So I mean, it's not like a whole new thing to learn, right? So what you can do is, so what we do, in fact, is we expose a certain interface. Like you have to say, what are my observations for my current state, right? And all of these simulations that we're tackling, you have to understand, are discrete event simulation tools, right? So there are discrete steps in time, and this discrete event processing is also pretty much what reinforcement learning systems use usually. And so if you, for instance, if you look at OpenAI Gym, they have environments, right? So one of the key methods you have to implement to define an interface is a function called step, right? And so this is pretty much more or less in a simulation the same thing, right? So a step is the next step in whatever you're trying to simulate in your environment. And what comes out of it? A set of observations about the world, the state of the world there, that is relevant for the reinforcement learning algorithm. Then you also have to define rewards, right? Which is like a new component, but it's very, very similar to what you would do if you define use with an out of the box optimization algorithm. You still have to define what is your goal with the simulation, what do you want to optimize for, and that is fairly similar as well. And the third thing is that is required is you have to specify when your simulation and your reinforcement learning episode is done. And that last part basically doesn't need any explanation, because that's mostly already implemented by the simulation modelers. And so there's a certain goal that is reached, or a certain state that doesn't allow you to move anymore, or there's a hard time constraint on your simulation, and then it's just over. And that's pretty much the same thing that you need for reinforcement learning as well. And now you have it. And under the hood, with all that information, we can build an actual reinforcement learning environment with all the bells and whistles, and apply all the complicated configurations, and choose an algorithm for you, a hyperparameter configuration, so that the simulation modeler doesn't have to be exposed to that and still get hopefully good results, right? So we basically have an interface that speaks their language, but connects to something that can do reinforcement learning. Yeah.
So it seems like, let me drill down. So there's two classes of problems. The first one is, I have an existing simulation happening in one of these software, say AnyLogic, and then now I approach Pathmind and say, I want to see if I can get better results if I use reinforcement learning with my existing problem. So at this point, Max, I'm sure it depends on the actual nature of my problem, is how easy would it be to translate my existing simulation over to an RL-based solution?
Yeah, right.
Does it
So with the
require a
current
lot
solution,
of? Does it still require a lot of consulting, engineering, or can I do it myself?
it depends. I think generally the interface that you have to fill in is not complicated per se, but of course it needs a certain mindset and an approach to things. But mostly what we see out there consulting with customers and potential customers is that like the first thing you do is you install a plugin into AnyLogic. And once you do so, you can open it, and it will essentially guide you through what you have to do. I mean, it still needs a bit of explanation, but it's I think quite straightforward. It's essentially what I just told you. Like you need to provide some information, but it's all built on top of your simulation, right? So most of the time, you don't have to fundamentally change your simulation at all, right? Why would you? It's kind of the engine that underlies everything, right? So that's the state space that is the truth. But you might have to work around a bit to expose the right observations and the right rewards. So sometimes the problem statement, as you put it in your simulation software, doesn't quite fit how you would translate this into a reinforcement learning problem. But sometimes it's just fairly obvious, right? So most of the time, I think it's you gain a certain intuitive understanding of what has to be done.
So a follow-up question is, now I have another set of problems, which is I have a complex simulation that I tried using the existing back end of the simulation software, and it didn't really work. Have you seen situations where that's the case, and then when you come in with the reinforcement learning approach, reinforcement learning is somehow able to tackle more complex simulations than the existing software?
Well, certainly. I mean, we have a few customers that have approached us with their simulation models, and they have a given set of heuristics and don't really know how to improve that. And certainly we've seen cases in which reinforcement learning outperforms their solutions.
I see.
But it's not always the case that it's necessarily the more complex simulations that qualify for that, right? So it's just it could be like a lot of factors that come into play, right? So for instance, in the example of the car company that I mentioned before, so one thing that you have to keep in mind is how stationary is your environment. Like, could it be possible that a new car has to be produced on the fly all of a sudden? So like, is there something like a turbulence? There's something that changes your outlook. Like if you pre-compute an optimization problem, right, and have like a solver, it can't react to a new information like that. You would have to recompute every time something changes there, right? So especially for non-deterministic environments where there's a certain stochasticity in the problem, that might just not work out. And so in these cases, we often find good solutions there.
So reinforcement learning can be computationally intensive, right? So you probably read stories about how some of these research groups like DeepMind may have spent gobs of money and let their simulations run for weeks and weeks on end. So what is the acceptable turnaround for users of simulation modeling software? I mean, are there cases where reinforcement learning will just take too long?
Possibly, yeah. I mean, there are certain considerations that we have to be smart about in our backend, right? but also like there's a few things that we can help with. For instance, like if you have a few ideas at the same time, like you want to test out, I don't know, maybe a handful of reward functions. You can do this in parallel, right? So like even if you don't have any compute resources locally, you can outsource this to our web application and just fire and forget, and look what your results are later. And so this is something that certainly already helps you, right? Because you can still focus on your crafting your simulation tools, and then run a few experiments and see what it does there. So it's not, I'd say most of the cases we had, sometimes we had to increase the capacity of the models, maybe deepen the networks a little bit, but usually we kind of start small so that it's not too computationally intensive. And also you have to keep in mind that sometimes it's also fairly reasonable to kind of scope down the just decrease the scope of the problem setting, right? So maybe you can't solve the problem in the most general setting for each imaginable factory, for each setting of each object in the factory, but maybe you can have like a useful restriction for that, and then your data set and your configuration and state space kind of shrinks, and then it becomes computationally feasible again.
And also, as you hinted earlier, some people may have heuristics already that they're working with, which to me the heuristics would represent domain knowledge. So is it possible, Max, to start with that domain knowledge, as use that as your starting point for the RL?
Yeah. So this is something we want to look at more in the future. So we've done a few experiments with kind of expert demonstration or inverse reinforcement learning, where you first generate like an expert generated offline data set, and then let an RL agent pick up from there. So this is not only technically feasible and fairly easy to pull off, but it's also a direction we're actively pursuing. But it's not in the product yet, right? So, but it's certainly very interesting, and I agree with you. It's kind of appealing. I mean, it's not only the heuristics that the expert knowledge comes in, but it's also like sometimes the simulation modelers in consulting can tell you exactly what a certain part has to do and how it has to move. So there's certainly something that can be leveraged there. It's just a matter of it might be too expensive to leverage experts like that. But in principle, like the process and letting RL pick this information up is certainly very interesting.
So one of the things that you folks are able to do, since you use RLLib, which is the reinforcement learning library built on top of Ray, is you can do distributed computing, right? So you can scale out on a cluster. Has that come in handy? Has that proved useful to be able to run all of these simulations in parallel?
Yeah, so we're fairly happy with Ray as a backend, and the integration with not only RLLib but also Tune for hyperparameter optimization, because that helps out scaling immensely, right? So we have usually we do this on a fairly training on a fairly large cluster, and so having kind of all the building building blocks in house from one open source vendor, so to speak, is fairly great, because it all integrates well, and so it's easy to run a lot of experiments like that.
But the de facto, the incumbent is the back end of the simulation software, and they're not distributed, right?
They're not distributed, no. But I mean, yeah.
So then, by definition, you folks might be able to handle more complex scenarios. because you can do distributed computing?
Well, it depends on how you want to look at it, but because I mean, you can still, let's say, inside AnyLogic, you can still run parallel Monte Carlo experiments or something like that, right? So have like multiple processes there, and also you have to keep in mind that when moving to reinforcement learning, we're not just cutting everything. We're actually bringing the simulation with us, right? So this is a standalone application that we export, and of course it's picked up by this distributed computing setup, but it's still it can potentially be bottlenecked by that communication process. I mean, we're I think very smart about how we do this communication between this Java-based simulation model and the Python world that runs the RL, yeah, and that bridge is pretty smart and efficient, but there's still some overhead, right? So you lose something there, but it's certainly not like here's the tool and we do something completely different, right?
So this is so now that you've been doing this kind of RL and simulation software for a while, do you envision this is something you would teach your students? I mean, as an example, I mean, some of the more advanced students.
Yeah, so we're in talks about having a reinforcement learning course as well, which I very much would like. So it depends on when this would start, but honestly, I'm quite psyched about this whole new world of possibilities, so to speak, right? I mean, you have a lot of sandboxes in reinforcement learning already, because I mean, luckily a lot of the big research labs open source many of their environments, so you can play with them. But it's also kind of cool to have direct access to a problem that reflects an actual customer's needs. Like oftentimes those examples you find are more like toy examples and quite playful, but personally I find it very motivating to see something that somebody really cares about and needs to have solved. And yeah, so I mean, it's certainly a possibility, but like I wouldn't go down the path of having like maybe an AnyLogic integration, because learning AnyLogic is a steep learning curve. It's like a quite heavy GUI, because it does a lot of stuff, right? It's very, very powerful, but it takes so long to learn properly, which is why I would rather do something with maybe a pure Python-based model, maybe, right? So we're planning in the next iteration also to have access to more, open Python-based models instead of having to rely on stuff like AnyLogic, right? So we want to expand our scope to integrate with other tools as well, and the Python world itself might be interesting as well. So because there's discrete event simulation software in Python too, right? It's more basic and it lacks a lot of the convenience, but you can still do it. So and we're in the process of evaluating if there's a market for that as well. But certainly it would be easy for students.
So I'm not familiar with AnyLogic, Max, but do they support multi-agent?
AnyLogic itself? Yeah. AnyLogic doesn't have any. I mean, do you mean multi-agent in the reinforcement learning sense?
Yeah, multi-agent problems.
Yeah. Yeah. The problem is, and that's why I'm asking. The AnyLogic has the concept of an agent, and it's actually fairly central to AnyLogic, but they mean something else by it, right? So you can have agents, and those are the objects of your model, so to speak, right? So I don't know if you have like a classical traffic light example, maybe, and then the cars would be your agents, right? But certainly, many times, not always, but oftentimes that does translate one-to-one to a multi-agent scenario in reinforcement learning as well. But you have to be careful about this, and you see how this can cause problems, because we have a checkbox that says, "Is this a multi-agent problem?" And they ask us, "What do you mean? Like there are several agents." Of course it is, but sometimes you have more like a different view on your reinforcement learning problem, because maybe in the traffic light it's more of a centralized God view on the problem. Some central controller that controls all your traffic lights or something like that, and then the agent for the reinforcement learning setting would be something else than the agent for the modeler, right? But in short, the answer is yes, right? We have that. Yeah.
So another hat you wear is open source. So you do a lot of personal work in open source. Right now, you're the maintainer of a popular library called HyperOpt, which actually you're unusual in the sense that you're the maintainer of HyperOpt, but yet you're very enthusiastic about Tune as well. Yeah. So that's good, actually, because basically anything that solves your problem is welcome, right? So what does it mean, Max, for our listeners who do not actively participate in open source? What does it mean to be the maintainer of an open source project day to day?
Well, it can mean many things, right? It depends on the project that you're working with and the scale that it has, right? So I have a lot of Python tools and libraries of my own, of which I'm kind of the sole maintainer and author, and that is something else than maintaining a mature project that has been used for many years, right? And I kind of grew into this role by doing other open source work as well, right? I think I started something like in 2014 or so. I started with first commits, and I think I first worked a lot on Keras when nobody, including the creator, I think knew how big it was going to be, right? And wrote a lot of extensions for that. And one of the first extensions for Keras I wrote is called HyperRus, which is kind of a connection between HyperOpt and Keras. And so through HyperRus, I made my way into kind of the HyperOpt core library and did a few bug fixes, ported it to Python 3 and stuff like that. And but nowadays, I mean, since it's a more mature project, maintaining HyperOpt for me means more, well, how can I say that? I mean, I'm more of a manager of the project now, yeah? So I can't do much of the individual contributor role, and I'm happy to have some time left at all, right? But it's certainly interesting because it exposes you a lot to the politics of open source as well, right? And you, for instance, you have to deal with upcoming new fancy tools that do similar things as well, right? But it also, I mean, in HyperOpt, like the last big feature we had, I guess, was a collaboration with Databricks. I think a company which you're also an advisor for.
Yeah.
So we talk about all of them, and so Databricks did a Spark integration with us, and so we were pretty excited about that, right?
So how does HyperOpt compare with Tune at this point? So do they compete, or do they overlap? So how does that how would you frame it?
Yeah, so I would say right now, if I look at the open source world, just to give you like the landscape, I think there's basically three big open source hyperparameter tools left, and maybe there's new ones coming, I'm not sure, but there's essentially HyperOpt, and then there's Optuna by Preferred Networks, which is essentially more or less like a clone of HyperOpt. So I would have preferred them to actually just contribute to HyperOpt instead. But they are basically more or less the same thing, right? But Optuna being
So
on the rise.
Chronologically, they also happened after.
Optuna came after,
Okay,
yes. So it's kind of a rewrite with a slightly better API and a few more features. But and HyperOpt has been like the old champion and is now being challenged, right? And Tune is kind of different because Tune allows you to integrate HyperOpt actually, right? So like HyperOpt's main algorithm, TPE, tree of Poisson estimators, has been invented by the original author who doesn't have time to maintain the project anymore, James Bergstra, who was also actively involved with other open source tools, right, like Theano. And so he runs his own company, so it's kind of difficult for him to do that still. But he had this paper about TPE and wrote the tool essentially and open sourced it. Right, and this main algorithm is still kind of very competitive for machine learning setups. And in Tune, you can actually select TPE through HyperOpt, right? So it's one of the available algorithms in the backend. And I think this explains a lot also about
they complement each other in some ways.
In some ways, I mean, yeah. I mean, look, like if you look at RLLib, you have different backends. You can use TensorFlow models and PyTorch models. If you look at Tune, you can use different libraries that work in the background, right? So, and one of them is HyperOpt, but you also have a lot of algorithms of your own. And just generally speaking, I think for me, like, and I say this as a HyperOpt maintainer. Tune is the clear winner down the road because like it's fairly well architectured and it integrates with everything else, but it's still well, it's just better, and it's built on the Ray interface, so it has all the benefits of that as well, and integrates with all the other stuff that you're building around that. And so yeah, so I'd say in 2020 I would certainly bet on Tune.
So then, and actually now, as you pointed out, you also happen to use Tune in the context of Pathmind, right?
Mm-hmm.
Yeah.
Yes, exactly. So
Speaking of open source, so since you're involved with open source, so here's a question I ask people who are core members of open source projects. So first question, Max, is what metrics do you track? Besides GitHub stars. Yeah, to track progress of your project. Let's say you start a project tomorrow. Besides GitHub stars, what would you start scrutinizing?
Well, yeah, I mean, I guess it's different for, like, if I would do this full time, and I've done full time open source software maintenance for a couple of years now, then it's certainly different, right? I think so. I mean, one of the markers of health is how many new issues get opened, and how quickly the response time is. Right, so like there's a lot of tricks to kind of let old issues become stale very very quickly, and it's kind of a trickery. But oftentimes you don't get around quick enough to get behind all the issues that people are facing, and that can have many root causes, right? So I mean, oftentimes. And I see that in HyperOpt in particular, which is why I invested a lot of time in documentation, which I don't have any trackers or markers for, right? I mean, I could check, I don't know, Google Analytics, but does it really tell me anything? I'm not sure, like because I'm not doing this as a company, but like in my free time. But what I've seen is that this is essentially like an FAQ, because a lot of the issues were recurring issues where people were asking, so how do I use this now? Like, and there were some of the questions were coming again and again and again, and so this was something that I was definitely having a look at, and to see how I could improve, right?
Speaking of this topic, actually, so by the time this episode comes out, I would have published this post, but I recently did a Twitter poll uh, uh, asking core contributors to open source projects how they interact with users. And the background for this, Max, is I'm noticing that more and more of these projects use Slack. And don't get me wrong, Slack is great because you can get in if the core members are active, you might get responses right away, so instant response, and also very personalized response. But a couple of drawbacks. One, it's not indexable by Google.
Oh yeah.
So, and then depending on the project, maybe the project does not have the funds to pay Slack, so the archive is gone. So a lot of knowledge gets lost. So I go into some of these open source projects, I look at the threads, I'm going, man, this is valuable information that they're, if it were just outside in a forum or on a mailing list, Google can index, and then now me as a new user can type a question in a search engine, and boom, here's my answer, right?
Yeah, true.
So how how do you, what's
Yeah.
your advice to open source projects in terms of this? My thinking is there's an opening here for someone who can build something that has some of the characteristics of Slack, which is immediate personalized response, and then the forums and message boards, which are searchable, archive, indexable. What's your advice? It seems like there's a generational thing here too, that the newer open source projects gravitate towards Slack. Am I missing something?
Well, yeah, to be honest, you have to be able to afford time-wise to be open to something like a synchronous communication channel, right? So this is something I simply cannot afford. Like it would drive me crazy. Like this would lead to burnout. I can tell you, right? And so I mean, like from my work in the last couple of years, I can tell you that there isn't much that you can't do asynchronously, right? So for instance, if you allow people to go back and forth with you, they tend to think less before they approach you.
That's
right?
true. You craft your question more carefully, right?
Yes, exactly. So for that matter, I think Stack Overflow is quite useful, right? If you have certain questions. And but also, I mean, honestly, I'm not. I don't have much problems with GitHub issues as well, right?
Yeah.
So you can kind of misuse GitHub issues as like points of information where you say like, here's the new roadmap. You can put out as an issue if you like, or of course, I mean, you can have mailing lists, but I mean, this might be.
But there's
generational thing again.
There's levels of users too, right? So the new users may have a certain way that you have to interact with them, and then all the way to GitHub issues and pull requests, right? So
sure.
But the main thing is you want to preserve knowledge, right? If you can. And some of these tools you lose a lot of knowledge, it seems to me.
It's true. Yeah, I mean, but this is like a very difficult problem. Like I said, I try to slowly but surely incorporate recurring themes into documentation and FAQs and so on, and answer Stack Overflow and be informative on GitHub issues. But yeah, I mean, there's only so much time in the day, right? And so I think the funding problem is more of an issue for me. Like I'm more and more pessimistic because about open source in general, but also about my personal work, because I realize that it becomes more difficult for me to be active in such maintenance tasks. Well, just because there's no, not because I'm after like big money or anything, but you see, like if Tune, for instance, is maintained by a team that is well funded and backed by a company, and they're on kind of the winning trajectory, it's difficult for me to say, all right, I'm opening a Slack now and throw a few more hours in. Yeah, so it's that's difficult to do. And so but I think that's a general problem, right? There's a lot of I think there was an XKCD recently where somebody said, like, here are all the building blocks and the Legos, and there's a very crucial tool by a guy that is solely maintained from Nebraska or something like that. And so like I think that's that is true, right? I mean, if you look at the integration of like the Spark integration with HyperOpt from Databricks, I mean, in hindsight, maybe I would have approached this whole cooperation differently, right? I mean, certainly, I guess there was monetary interest, and Databricks has kind of a vested interest in doing that. So why not work together as as professionals? And so, I mean, long term, I think a lot more companies should look into, I don't know, not only supporting more open source projects, but also hiring open source maintainers for projects that they use and have commercial interest in, right?
So let's close by having you do something that I know as a German you won't like, which is to predict the future.
Oh my gosh.
So, but it's a very specific prediction, Max, which is basically reinforcement learning. Let's look 2 to 5 years. Is it going to be something that is a routine technique that a data scientist will need to know? Is it something that will be taught in programs that you're teaching now? So, or is it just going to be still somewhat specialized and somewhat niche tool? So, is so the general question is is reinforcement learning about to go mainstream?
Uh-huh. Well, honestly, I don't expect it to grow much, but I do expect the good old deep learning hype to decrease a little bit. So like there will be less noise and maybe like a reversion back to to the mean, in that sense that you see other tools out there still competing, right? And I think it can be a very interesting and good tool in the given in the right settings.
Or
it will not go away.
Or is reinforcement learning, because based on your work now with Pathmind, is reinforcement learning, it's not that it's going to go mainstream for data scientists, but there might be backends that are going to be powered by reinforcement learning that we don't even know are using reinforcement learning. Just like Pathmind, maybe the entire simulation software becomes more reinforcement learning based, right?
Possibly. Yeah. Possibly. That's your prediction, right?
I think so. Yeah, because I think the technique itself is still a bit not as accessible as, like teaching someone how to do build a classifier, right? So reinforcement learning requires a little more careful thinking of casting the problem properly, right?
Yeah.
So until there's a way to overcome kind of that, just how do I frame my problem properly? Then I think it'll still be somewhat specialized. What do you think?
Yeah. Well, I mean, honestly, like when you follow machine learning or Reddit or anything, I mean, it's usually centered around stuff that works immediately today. But if we look at what we want to solve, like problems that people actually have in the real world, I think reinforcement learning certainly has a part in that to play, right? Like, because you just mentioned problem formulation, right? A lot of what you see out there, problem-wise, has this kind of property that you have a time-delayed reward, and you don't quite know what is my goal, right? It's not like the world out there isn't like a supervised problem inherently. Like you can focus on specialized tasks, but that kind of doesn't get you all the way, right? And I think a lot of that is true. And I mean, it's true for the processes we can simulate right now, and I think for simulations, reinforcement learning is best suited. And what will certainly happen is that looking into the future, we can simulate more and more things. So that's also true. And yeah, so I think it's there's a steady growth there, and certainly potential.
So you know what, you, me, and Chris should sit down and write a post basically around how to think in terms of RL.
Yeah.
The RL,
Let's do it.
how to get that kind of RL mindset. How do I cast my problem so that it fits into the RL framework, right?
Yeah.
So it doesn't. We don't have to get into the technical details. It's just here's how you think of a problem and put it into the kind of RL framework.
Mm-hmm.
Yeah. All right, and with that,
cool.
Thank you, Max.
Thank you, Ben.